All right, yesterday, life-changing event, we were talking about that number E. Really unfortunate that this doesn't have its own holiday too. But today, another life-changing event, we're going to talk about logarithms. Really opening a whole new door, a whole new area of mathematics. Very exciting. If you're not believing it, you need to believe it. All right, logarithms. The number one thing that I need you to remember is when you're finding a logarithm, you're finding an exponent. And you're going to get sick of me saying that. You're probably going to get sick of me saying that by the end of this hour. When you're finding a logarithm, you are finding an exponent. So, by definition, let b and y be positive numbers where b is not 1. The logarithm of y with base of b is denoted by, we write it log base b of y. And it is defined by the following. All right, we have log base b of y. When you're finding a logarithm, you're finding an exponent. So we're going to set it equal to x. We're going to set it equal to that exponent. Okay? Now, this will only happen if and only if. In math, that means it goes both ways. If this happens, then that happens. If this happens, then that happens. If and only if in mathematics means it goes both ways. If b to the x is equal to y. When you're finding a logarithm, you're finding an exponent. So what I need you to realize is this. My little base of b scoops up my exponent of x, and it's equal to what's inside, which is y. My little base of b scoops up my exponent of x, and it's equal to what's inside, which is y. Now, the way that we say this, we say log base b of y is x. But the most important thing I need you to take away from this is that a logarithm is an exponent. When you're finding a logarithm, you are finding an exponent. Most important thing that you can gain from today. All right. Now, because a logarithm is an exponent, that means that if we have something that is a logarithm, I should be able to write it with an exponent. So we have what is called two forms. Logarithmic form, where I write it with log, L-O-G, in it. Or when I write it with the exponent, we call it exponential form. Now, this is no different than printing your name and writing it in cursive. It's still the same name, but it's just written and it looks a little different. These are exactly the same, but they look a little bit different. So if I take a look here, I have log base 2 of 32 equal to 5. If I want to write that in exponential form, if I want to write that with an exponent, my little base of 2 is going to scoop up that exponent of 5, and it's equal to what's inside, which is 32. And that should be exciting, because 2 to the 5th is 32. 2 to the 5th is 32, so that should be exciting. Should make sense. All right. Now, we have log base 10 of 1 is equal to 0. So if I want to write that exponential form, if I want to write it with an exponent, my little base of 10 is going to scoop up that exponent of 0, and it's equal to what's inside, which is 1. All right, try C and D very quickly on your own. Just want to make sure everybody can write them as an exponent. Log base 9 of 9 equals 1. All right, Tara, what does it look like for C?
9
Beautiful. My base of 9 scoops up that exponent of 1, and it's equal to what's inside, which is 9. Fantastic. What does it look like for D? Ashlyn, what does it look like for D?
The first part is 1/5 to the negative second power is 25.
Beautiful. Now, make sure that it's all of that 1/5 to the negative 2 power. So I want to make sure I put it in parentheses. All of that 1/5 to the negative 2 power is equal to what's inside, which is 25. And they should make sense. 9 to the first, oh my gosh, that's 9. How exciting. 1/5 to the negative, okay, flip it over. 5 squared is 25. Yes, sir. Write it exactly as should be translated over to exponential form. Does that make sense? So leave it as 1/5 to the negative 2 equals 25. Okay? Anything else? Okay. Now, some special ones. We always have special ones. Special logarithm of 0. Special logarithm of 1. All right. We think our way through this. Take a look here. Log of any base. I'm going to call B the base. Log of any base of 1. Now, think about what that means is equal to an exponent. Think about what that means. B to some power is going to be equal to what's inside, which is 1. B to what power is 1? 0. This has to be a 0. My exponent has to be the 0. So log of 1. Log base 7 of 1, log base 10 of 1, log base 42 of 1. Any log of 1 is always 0 because our base to the 0 power has to equal 1. When I'm finding a logarithm, I'm finding an exponent. Yes, sir.
So like A, B, C, and D, like the 5, 0, 1, negative 2 are exponents.
Exactly. Here this is my exponent. This is my exponent. This is my exponent. This is my exponent. When I'm finding a logarithm, I'm finding an exponent. When I'm finding a logarithm, I'm finding an exponent. That is exactly right. All right. Now, log base B, log of B with base of B. All right. So I have log base B of B. Okay. So what this is saying is B to what power is equal to what's inside, which is B. So B to what power gives me B? 1. My exponent has to be a 1. If the base of my logarithm matches the base of my exponent, some very interesting things happen. We'll be talking about those in a little bit. All right, now evaluating the logarithm. Evaluating the logarithm. In this chapter, there are definitely going to be places where we're not going to have a calculator. Okay? So this is one where we will not have a calculator. All right. Now, remember you're evaluating the logarithm. When I'm finding a logarithm, what am I finding? The exponent. So really, ultimately, what this is saying is that we are finding the exponent. When you're finding a logarithm, you're finding the exponent. Okay, so to get this started, log base 3 of 81. All right, I know that I'm finding an exponent. So I'm going to set it equal to x, and x is the exponent I'm trying to find. X is the exponent that I am trying to find. Yes, sir. I could set it to any variable I wanted, really. I mean, it could be M for Matt. I just chose X because it's kind of a fan favorite. Most people just love X as a variable. My other favorite one is N, but doesn't get as much attention. All right? So, log base 3 of 81 is equal to x. X is the exponent. Now, what I want to do is write it using that exponent. So, if I were going to write it using the exponent, what would this be? 3 to the x is equal to what's inside, which is 81. All right, now, I look at this and I have 3 to the x. I look at the right-hand side, I have 81. Is 81 special? What is 81? 9 squared. Is 81 anything else special? 3 to the 4th. Now, because my base on the left is a 3, I'm thinking it might be smarter to write this as 3 to the 4th. Because if my bases match, what do we know about the exponents? They're equal, right? So x is equal to 4. Now I got a question for you. When we're finding a logarithm, we're finding what? Look at that. We found the exponent. Yes, sir. Yes, you got to know your special numbers. Now I got a comment for you though. Let's say we didn't know that, okay? Let's say that we got here and we see 81 and the first thing I think about 81 is what? 9 squared, right? That's all. Oh my gosh, I think 9 squared, I can't do anything else with it. Oh, but 9. Is he special? What is 9? 3 squared. So that means I have 3 to the x is equal to 3 squared squared again. Marcus, what would I do with those? Power to a power, I'd multiply. So 3 to the x is still equal to 3 to the 4th. Still going to get me there. It might take a couple steps longer, but it's still going to get me there. All is not lost. All right, let's take a look at B. B is another good one. Log base 1/4 of 256. Okay, what's the first thing I'm going to do? Set it equal to x. Set it equal to x. I'm looking for x. I remind myself that x is the what? Exponent. I am finding the exponent. Haley, how am I going to rewrite this? Okay, can somebody help us out? Justin? Beautiful. My base of 1/4 is going to get scooping up that exponent. I'm going to raise it to the x power. And it's equal to what's inside, which is 256. Okay, I look over on the right-hand side. I see 256. Dan's excited. Yep.
Are we going to know that x is negative?
Oh, we will in a second. Shh. If it happens to be negative, we will figure that out along the way, I promise. Okay? Give me 1 second to show you how that happens. All right, what are we thinking? 256, holy smokes. What are you thinking with 256? 16 squared. All right, I can do that. 1/4 to the x is equal to 16 squared. 16, what are we thinking? 4 squared. All right, so we got 1/4 to the x is equal to 4 squared squared again. So really 256 was what? 4 to the 4th. Okay, so I have 1/4 raised to the x equal to 4 to the 4th. Now on the left-hand side, I don't have a 4, I have a 1/4. The 4 is in the denominator. Does anybody have a thought on what I can do, Jacob? You bet, absolutely. If I want to get that 4 to the numerator, I'm going to make it to the -1 power. So 1/4 is really 4 to the -1 power to the x is equal to 4 to the 4th. All right, Aaron, what do I do with these exponents? Good. So 4 to the -1 times x is going to be 4 to the -1x is equal to 4 to the 4th. Now, if the bases are the same, Hunter, what do we know about the exponents? If my bases are the same, what do we know about our exponents? They're going to be equal, right? If my bases are the same, that means that my exponents have to be equal. So what is x equal to? X is equal to negative 4. And what does x represent? The exponent. So in other words, can we check this? You bet I can. Take 1/4 to the negative 4 power really quickly. It's exciting. Come on, people. Take 1/4 to the negative 4 power.
Have this. That wasn't accurate.
Yes,
It's 256.
it is. Remember, when you're finding a logarithm, you're finding an exponent. It's important to understand that. All right. Let's try C. All right, what's the first thing I'm going to do in C? Brooklyn, what's the first thing you want to do?
Do 10 to the x.
Good. Okay, I'm going to set it equal to x because I know that I'm finding the exponent. So you said that that's going to be
10 to the x
10 to the x
equals 0.001.
is equal to 0.001. Perfect. So 10 to the x is equal to, what is 0.001? Okay, what most of us think of it as what? Okay, some of us think of it as 10 to the negative 3. Some of us, I'm going to put myself in that boat, would never see it that way. I would never ever think about 0.001 being 10 to the negative 3. When I look at 0.001, I see, oh my, that's 1,000th. Is anybody else with me on that? Where is the 1? It's in the thousandths place of your decimal. I see it as 1,000th. I would never see that as 10 to the negative 3. Immediately. Is there anything wrong with seeing it as 10 to the negative third? Absolutely not. You're going to make your life a whole lot easier if you see it that way. But I'll be honest, I would not see it that way. When I think of 0.001, I think of the 1 is in the thousandths place, so that is 1 over 1,000. What is 1,000? 10 cubed. So that's 1 over 10 cubed. Now what do I need to do? Yeah, I got to get that in the numerator. So 10 to the x is equal to 10 to the negative third. So if my bases are the same, what do we know about our exponents? They are equal. So 10 to the negative third is equal to 0.001. If you saw this already as 10 to the negative third, you didn't have to mess around the way I did. But I would never see it that way. I'm being very honest in saying that. I always take my decimals and change them to fractions. I'm just a creature of habit. Yes?
So right when you get to 1 over 1,000, then you switch it to 1,000 and then the first is 10.
If you can go from 1 over 1,000 to 10 to the negative 3, that's perfectly fine.
Oh, like 1,000 is 1,000 and then the first and like that.
And then change it to 10 cubed and multiply your exponents. Absolutely another way to look at it, certainly. So far, so good? All right. Take a look at D. Try D on your own. Very quickly, try D on your own. Log base 64 of 2. Give that one a shot on your own. Log base 64 of 2. These are not easy. You got to do some thinking on these. You really got to do some thinking. Most of us did a great job with our first step. What did we do with the first step? All right, set it equal to x. And then what did I do? All right, my base of 64 to that exponent of x is equal to what's inside, which is 2. And then we got the haves and the have-nots. We got some of us that just quit right here. And I totally get that. You got to be persistent. You got to think it through. When you're finding a logarithm, I'm finding the exponent that makes that true. 64 to what power is 2? I might not know that right off my head, top of my head. And I won't have a calculator to help me. However, I look at that number of 64 and I think what? 8 squared. Okay, I think 8 squared. So a power to another power, what do I do with those exponents? Multiply. So that's 8 to the 2x is equal to 2. And then I wonder if I really got anywhere. Now I got an 8 and a 2 instead of a 64 and a 2. But I remember that 8 is special also. 8 is 2 cubed to the 2x is equal to 2. So on the left-hand side, what do I have? 2 to the 6x. Absolutely. A power to a power I multiply. Equal to 2. Now, if my bases are the same, what do I know about the exponents? They're equal. But what is my exponent over here? 2 to the first. So if my bases are the same, the exponents have to be equal. So my exponent is 1/6. My exponent is 1/6. Lots of people had it. Lots of people were on their way to working hard and getting there. All right. Common logarithm. There are only 2 types of logarithms that are special. 2 logarithms that are definitely special. The common logarithm and the natural logarithm. Now, the common logarithm is a logarithm with a base of 10. This is one of only 2 logs that can actually go in your calculator. Okay, this is one of only 2 logs that can actually go in your calculator. So in other words, if it is log base 10 of x, that is a pretty special one. That is one that my calculator actually likes. Now, on my calculator, however, you're never going to find it say log base 10. Kind of like with the square root, we don't put the little 2 in for our index. We only do it if it's like a 3, a 4, a 5, or a 6. When it is log base 10, we just write it log of x. We don't write the 10. If there's no number here, we automatically know that it is a 10. All right, another special logarithm called a natural logarithm. Deals with what we were talking about yesterday. A natural logarithm is actually a logarithm with a base of what special thing did we talk about yesterday? Base of e. That number e. If it has a base of e, if I am doing log base e of something, log base e of something. We mathematicians just don't like the way that that looks. Might be confusing. So we change that one completely. If we are talking about log base e, we will actually write that as the ln of x. We know that whenever it says ln, there's automatically a little base e here. Automatically a little base e there. All right, so won't happen very often, but sometimes we do need to use our calculators. So grab your machines if you don't already have them out, and get to use new buttons on that calculator. Take the log of 0.85. What is the log of 0.85? Won't come out nice, so we're going to have to round. Jenny, what do you get for the log of 0.85? Maybe 5?
Or, yeah, 6.
All right. If we round it 6?
Yeah.
All right. So log of 0.85 is about negative 0.0706. Now I want you to think that through. What base am I in? What base am I in here? 10. And this negative 0.0706 is the exponent. So very quickly, take 10 to that exponent of negative 0.0706. Very exciting. Oh my gosh, 0.85. When you're finding a logarithm, you're finding an exponent. All right. Take the ln of 22. Finding that fancy key on your machine. ln of 22. Approximately, what do we get, Brianna?
3.09.
About 3.09. All right, now ln is base of what? Base of e. So, as a double check, take e to the exponent of 3.09. When I'm finding a logarithm, I'm finding an exponent. What do we get? Pretty close to 22. It's a beautiful thing. All right, so we're going to skip example number 3 and go down to inverse functions. Inverse functions. What do we know about inverse functions? Tell me something about inverse functions. All right, to find them, we switch the x and the y. Absolutely. Now, another thing we know about inverse functions. Inverse operations undo each other. Inverse functions undo each other. When we are finding a logarithm, we're finding a what? An exponent. Now, the past couple of days, what type of functions have we been working with? Exponential. And where has our x been? In the exponent. Well, if we're talking about inverse functions, logarithmic functions, such as g of x is equal to log base b of x, and exponential functions such as f of x is equal to b of x, they are inverses. They will undo each other. X being in the exponent and a logarithmic function are inverse functions. They will undo each other. Okay, so let's take a look at that in action. First of all, simplifying our expression. This once again is another spot where we will not have a calculator. No calculator. When you're simplifying something like the next few things, we will not have a calculator. E to the ln of 9. All right. E raised to the ln of 9 power. Okay, now the base of my exponent is e. In my exponent, I have the ln of 9. All right, ln of 9. ln is log base what? Log base e. Now, we know that exponential functions and logarithmic functions are inverses. They undo each other. Here's the deal. If the base of my exponent matches the base of my logarithm, and they are inverses, that means that they undo each other. So they will cancel. If the base of my exponent matches the base of my logarithm, they will cancel. So, let's take a look at b then. Log base 3 of 27 to the x. Now, what is the base of my logarithm? 3. What's the base of my exponent? 27. Do they match? No. All right, what's 27? 3 cubed. He's special. So I can say, well, this is log base 3 of 3 cubed to the x. Now, what would I do with those exponents? Multiply. So log base 3 of 3 times x is the 3x power. All right, what is the base of my logarithm? 3. What is the base of my exponent? 3. The base of my exponent is 3. The base of my logarithm is 3. They're going to cancel, and what am I left with? 3x. Now, when you're finding a logarithm, you're finding a what? An exponent. Yes, sir.
Is it like 2 to 27 or times 27?
Nope, it's log base 3, this is a subscript, of 27 raised to the x power. Does that clear it up? All right. Continuing on. All right, finding the inverses. Finding the inverses. We've already touched on this. What do I do to find the inverse? Switch the x and the y. We've got to switch the x and the y. So if it's y equals 8 to the x, that means I'm going to have x is equal to 8 to the y. Now, just a comment. When we started out, where was the x? Exponent. It is an exponential function, which means that its inverse has to be written as a log. Its inverse has to be written as a log. Now, when you're finding a logarithm, you're finding an exponent. So when I switched my x and my y, what was my exponent? Okay, when I switch them, my exponent is y. Where is that y going to go if I write this as a logarithm? You've got to understand the definition of a logarithm. It's going to go on the right. Because when I'm finding a logarithm, I'm finding the exponent. Well, in this case, my exponent is the y. Now, where will the 8 go? It's the base of the logarithm because the 8 scoops up the y and it's equal to what's inside, which will be the x. We've got to understand the definition of the logarithm. All right, let's skip down to C because hopefully it'll help you remember or remind you about A. All right, so if I look at A, to guide me through C, if I look at C, what kind of function is this right now? Exponential, which means its inverse better have a log in it. Okay? Now, what do I do to find the inverse? Switch x and y. Okay, so where there was a y, now there's an x. Where there was an x, now there's a y. All right, what am I going to do to start getting the y by itself? I'm going to add 4 when I get started. Very nice. So x plus 4 is equal to 3 to the y. Now, can I leave it like this? Why can't I leave it like this? Yeah, I have to get y all by itself. If you know anything about writing the equations in standard form, I need y all by itself. Y right now is in the exponent. That's not okay. I need to get y all by itself. If y is in the exponent, that means that I need to write it as a log. All right, tell me where some of these pieces are going. All right, my y is the exponent, so it's going to go on the right. All right, my base is 3 because it's the 3 of my exponent, base of my exponent. So my 3 is raised to the y, and it's equal to what's inside, so what's going to go inside of here? That group of x plus 4, and I want to keep it together, so I'm going to put it in parentheses. All right, now let's take a look at B. Let's take a look at B. All right, what kind of function is this to start? It's a logarithmic, right? It's a logarithmic because I've got a natural log in here. Now, if it's logarithmic, what will its inverse be? Exponential. So when I'm done with the inverse, where should the x be? In the exponent. My x better be in the exponent or I made some major errors because it's got to be exponential. Okay, so what do I do to find the inverse? Switch the x and the y. So where there was a y, now there's an x. Where there was an x, now there is a y. Okay, ln. ln is a logarithm with what base? Base e. Now, what is that e going to do? Does anybody have a suggestion? Anybody got a thought? All right, it's going to be raised to the exponent. What is my exponent going to be? E is going to be raised to the x power, and it's equal to what's inside of that logarithm, which is y minus 4. And then I got to add 4 at the end. So e to the x, add the 4, is equal to y. Notice, it started with a log, it ended with x in the exponent. It started with x in the exponent, its inverse ended with a log. It started with x in the exponent, its inverse ended with a log. Exponential and logarithmic functions are inverse functions. Remember that the basis to find the inverse, we do what? What do we do to find the inverse? Switch the x and the y. Yes, sir.
So ln is just ln e.
The ln is a fancy way of saying log base e. We just write it differently. I don't know. I got nothing. I'm thinking it had to do with some mathematician wanting to name something in a special way to get his name out there, but I could be wrong. Anything else? Okay.